Welcome to my project. Now we discuss about comparison of edge-based images using homogeneous diffusion. It is the modified title of edge-based image comparison with homogeneous diffusion. Image comparison is an application of data comparison that encodes the original images with few bits. In recent years, the development and demand of multimedia product grows increasingly fast, contributing to insufficient bandwidth of network and storage of memory device. Therefore, the theory of data compression becomes more and more significant for reducing the data redundancy to save more hardware space and transmission bandwidth. In computer science and information theory, data compression or source coding is the process of encoding information using fewer bits or other information during units. The an encoded representation compression is useful because it helps reduce the consumption of expensive resources such as hard disk space or transmission bandwidth. In this paper, we briefly introduce the fundamental theory of image compression. In this process, it is well known that edges contain semantically important image information. In this paper, we present a lossy compression method for images that explores its information at image edges. These edges are extracted with the Markov operator followed by heuristic thresholding. The locations are stored in lossless way using JPEG. Moreover, we encode the gray or color values at both sides of each edge by applying quantization, subsampling, and PIQ coding. In this decoding step, information outside this encoded data is recovered by solving the Laplace equation. We implement with a steady state of homogeneous diffusion process. Our experiments show that the successful method outperforms the widely used JPG standard and can even beat the advanced JPG 2000 standard for cartoon-like images. Edge detection is an image processing technique for finding the boundaries of objects with images. It is the flow diagram for our proposed system. In our proposed system, first we give the input image for compressed image. That input images go to the preprocessor step. In the preprocessor step, we use Gaussian filter to reduce the noises in images for image compression. If any noises is there in image compression, it affects the process. So we remove the noises in images by using Gaussian filter. And then noise removed images is go to the edge detection process. The edge detection is an image processing technique for finding the boundaries of objects within images. It works by detecting discontinuous in brightness. Edge detection is used for image segmentation and data extraction in areas such as image processing, computer vision, and machine vision. Edge detection is the name for a set of mathematical methods which aim to identify new points in digital images and with the image brightness changes sharply or more firmly. As discontinuous edges are significant local changes of intensity in an image and typically occur on the boundary between two different regions in an image. Goal of edge detection is produce a line drawing of scene from the images of the change. Important features can be extracted from the edges of one images. Then the edge detection images go to the encoding process. In the encoding is most images the neighboring pixels are correlated and thus contain redundant information. Our task is to find less correlated representation of the images. They perform redundancy reduction or irrelevancy reduction. In this process, we encode or compress the quantized values in lossless manner, which gives better compression overall. It uses a model to accurately determine the probabilities for each quantized value and produce an appropriate code based on this probability, so that the resultant output code stream will be smaller than the input stream. Then we go to the decoder process. In decoding process, as a first step of the decoding base, we split our encode file into JPEG data and PAQ data part. Both parts are then decoded by using JPEG and the PAQ method respectively. We reconstruct the quantized colors obtained by the PAQ part. The pixel values between sampled points are computed by using linear interpolation along each edge. Higher order interpolation do not give any advantage since the pixel value hardly vary along one edge. The decoded pixel value have to be placed at the corresponding positions in the final image. The JPEG data provides us bi-level edge image of the original image size. Give the image size and the edge pixel position. The pixel values are arranged around the edges in the same order in which they have been encoded. Then we go to the reconstruct process. We have decoded the edge location and the pixel values surrounding the edges. The idea is now to apply interpolation to reconstruct gray or color values of pixels that lie between edges. We keep the pixel values at the position obtained in step 1 and use homogeneous diffusion for interpolation. This is the simplest and computationally most favorable in-patienting approach based on partial differential equation. Missing data is reconstructed by computing the steady state of the diffusion equation, where the given values are considered to form distinct boundary state. Thus, the reconstructed data satisfy the Laplace equation. Such a partial differential equation can be restricted in the straightforward way by finite difference. Interestingly, diffusion-based inflating for image edges reassemble and classical finding in biological design. And then we save the reconstruct compressed image in specific folder. Now I go to demo our project. First right click the m1.length file and then run the file. The process window will be open and then go to start the process and then first load the input image from any in your computer and then preprocess that image, and it is a noise removal image and it is the histogram value of input image. And then go to the next step. We detect the edge of the original input image and then encoded that image. And it is the encoded value of given image. And then we go to the next process and then it is the decode the encoded image and then it is the edge reduction image based on the encoded value, and then reconstruct that image and store that images in folder at the given name, and then it is the histogram value of output image, and then press the home button to go to the another process, and I will press the exit button to exit the command window. Thanks for watching video.